So, hi everybody, and welcome to another episode of Schooled In. My name is John Lunn, aka Jonnychipz, and in this video series, we take a deeper dive into some of the awesome cloud technology areas. I'll be joined by a fantastic guest from outside the tech community who have very kindly taken the time out their day to come and school me in a particular tech topic. So whether you're watching this on YouTube, Twitch, Twitter or LinkedIn, thanks so much for tuning in. Please do take part in the chat below. Drop us a comment, a like, a subscribe. That would be really appreciated. Okay, so over the years in software development, we've become accustomed to the traditional relational database type of back-end storage to act as our application support. Since the rise of cloud computing, a number of scalable, non-relational database technologies have enabled application developers to lower that barrier of entry when it comes to creating applications. Couple this with super responsive, globally scalable and highly available technologies that products like Cosmos DB offer, you can start to understand why these DB technologies are becoming more and more prevalent. So to help me understand the place of these database technologies, I'm super thrilled to be joined by Senior Product Manager for Azure Cosmos DB at Microsoft, based out of New York, Mr. Gahl Levy, who today is going to school me in the advances of Azure Cosmos DB for Mongo DB. Hey, Gahl, welcome to the show. Thanks so much for joining me. How are you doing?
I'm doing great. Thanks for having me on the show.
Oh, not at all, not at all. So, yeah, I mean, it was a tongue twister, that little intro there. Azure Cosmos DB with the Mongo DB APIs. Look, Gahl, before we get into all this database goodness, I don't know if you want to give yourself a little bit more of a broader introduction. And, yeah, super looking forward to having a chat to you around these areas.
Sure. So I found myself working in the database industry for almost the past decade, and I just keep coming back to databases. And it's really interesting seeing the market kind of form, with NoSQL databases, or you're relational initially, and then go into NoSQL, and then into these APIs to really focus around developer velocity and making sure developers have the tools they need to work as efficiently as possible. And I'm really excited to talk about the Mongo API and the things we have new out there.
Yeah, and I think for me personally, Cosmos DB, I understand it's one of those technology areas. I know it's a database technology that's available in Azure. Maybe we'll start there. What is it with these database technologies now, Gahl? In the cloud, what are the differences between this non-relational versus relational database? I mean, is that a good place to start, maybe, to help our viewers understand where we're going with these database technologies?
Definitely. I think a good way to get started, I guess, is to just go through our documentation here, because it spells it out pretty clearly, and we can just walk through it, and that way any of your viewers can also walk through it afterwards. So the first thing to start off is, you have relational databases, and you have what we call NoSQL databases, meaning not only, relational databases. So it's not that the feature set is completely different. They do share features, but there are differences there, and it depends on the database you're actually using. So one of the key, benefits and differences is the high throughputs you can get with non-relational databases, such as Cosmos DB and especially Cosmos DB. You might, your viewers might or might not know this, but there's two different ways of scaling a database. One is vertical scaling, where you're getting larger and larger machines, and eventually you hit a limit there. The second way is horizontal scaling, where you can just keep adding more and more machines, and that's essentially limitless, because you can just keep adding more and more machines, and that's what Cosmos DB excels at. So it's essentially a distributed database where you have many computers functioning as one singular database, and you can scale up and down very quickly to meet your users' needs and demands. An additional benefit of that is you can scale, your database across different Azure data center regions around the world and achieve very high availability, meaning that if a region or storm takes out your data center, your database stays alive. And this is not really achievable with many other technologies. And the last part, I guess, about this section here is also the latency guarantees, because you can have your data served in different regions around the world. You can actually guarantee very low latency operations from many different areas. And Azure Cosmos DB excels at this because we have multi-region write, meaning you can write in addition to read from the same database from different regions, which is pretty amazing.
Yeah, that makes a lot of sense. So, I mean, my little knowledge on kind of non-relational databases is, that ease of use, that ease of spinning these kind of platform as a service type databases. But why not use something like, PaaS offering of Azure SQL? Is it just that scalability piece, Gahl, or are there other kind of motivations as to why developers are starting to use these document database types now going forward?
Yeah, so scalability and high availability are really important from like a operational sense of running your database and serving your users. But there's also, in terms of developer velocity, as a developer, I'm writing my application. I want to be able to use the database in a certain way, and we want to make that as efficient and as easy as possible for developers. So one kind of trend from this is I can never say this word. It's like hierarchical data. I always mess this up. And they can never say it, but basically this kind of object-oriented design where you can store your data in as JSON documents, and you'll hear this term thrown out a lot, schemaless design, meaning that you don't really need a defined schema. You can have different documents within a collection, essentially a table, with a different schema there. And instead of the schema management happening at a database level, it gets moved over to the application level, which is very convenient and easy for developers as they're developing their app, since they don't have to stick to one thing as they're developing their app. Obviously, it's important to stick to a schema later on, but it makes the back and forth much easier when you're developing, having everything in a JSON document as we have here.
I'm with you. That makes a lot of sense. So I guess in that traditional relational database type, that schema would have traditionally been managed and maintained by a database administrator that will put it in. And I'm guessing they're pretty rigid. You need to put data in that database table with specific formats like strings, number values, date ranges. And what we're saying is with document databases like Cosmos DB, it's really just a JSON file. So it's up to us as the app developer that the types of data that we include in that document effectively.
Exactly. Yeah. And this is all just contributing to developer velocity there. And that's why it's there.
No, that's cool. That's cool. So I know we've had some great announcements. Well, to be honest with you, I try and stay quite close to the announcements of, as many of the Azure services as possible, on the Azure news and updates pages. And I see Cosmos DB appearing quite frequently, and I've seen it quite frequently appear over the last couple of years now, and it's gone from strength to strength. So where are we today, Gahl, in terms of Cosmos DB? How does that relate to Mongo DB and the APIs that we can interface with it? And how does that all hook together?
Yeah, so along the lines of developer velocity and developer experience there, Cosmos DB is very unique, as in we actually offer several different ways of interacting with the Cosmos database to meet developers' needs. And where I mean that is, for example, imagine you're a Mongo DB developer and you're used to using MQL and stuff like that to interact with your database. We offer a Cosmos DB version of MongoDB, so it's Azure Cosmos DB for MongoDB, and this allows users to interact with Cosmos DB as if it were a MongoDB database. So you get all of the benefits of the scalability, elasticity, and developer experience with Cosmos DB, but you get to use it as if it were a MongoDB database and interact with your applications that way, and not have to really change your applications much to make it work correctly.
Cool, makes sense. And I can see there's a few different APIs that will hook into Cosmos. So I guess, Gahl, that's all around, like you say, that developer experience, what the developer is comfortable with using, what they're used to using. We can just wrap that Cosmos DB with this API and interact as though it were that particular type of database.
Yeah, and what that means also is your existing tools like Robo3T, Mongo Compass, all those things, Mongo Shell, these will all work with Cosmos DB as long as it's a Mongo API account. They will all work in the same way, but you'll just get the elasticity, instantaneous scalability, serverless automatic sharding, all those benefits of being able to scale and not have to worry about managing your database, but still be able to interact in the same way as if it's a MongoDB database, and all the the benefits of that.
Makes sense. Makes sense. So, I mean, in terms of where we're going with this technology, we've kind of described how its developer velocity help those developers really get up to speed as quickly as they can. Low barrier to entry with that database backend. Clearly, you mentioned that undoubtedly moving forward, when the application is further developed, there probably is going to be some form of schema that needs to be adhered to. But where do we stand today, Gahl, in terms of what kinds of applications are being developed? Are we in this? Clearly we're moving well away from the monolith type application and more towards these microservices, containerized type applications. Where does Cosmos fit into that world now?
It's a good question. So Cosmos DB, it's also unique in a way where you can actually choose. So you can choose the consistency level you want. So we do support asset transactions, so you can do it that way. Obviously, there's the performance hits when you do that, but you can actually choose on a per use case basis what consistency level you want and what availability level you need. And doing so allows you to kind of tailor Cosmos DB to each of your use cases. And in addition with that, considering you can also choose the API you interact with it, you have a lot of variables you can change in terms of what use case works and what use case doesn't. So we see all the way from like banking to IoT to many different types of microservices. All of that use Cosmos DB just in different ways, and that's pretty unique in the database industry.
I guess it's down to the relative ease that these databases can be, and the containers can be spun up and programmatically spun up at that, and destroyed if needs be. So, yeah, I mean, are there any features and things that we can talk through now, Gahl? In terms of the interaction with MongoDB, any announcements that we've had over the last couple of months, things like that?
Yeah, so we've actually released two major features at Ignite. One of them is definitely tailored towards just developer flexibility, and that's 16 megabyte document support. So imagine you have a JSON document, it's a certain size. We used to limit that size as 2 megabyte. Now we just raise that up to 16 megabytes, and that just gives you more flexibility in terms of which documents you want to have in there, migrations, that sort of thing. It's worth noting it's not a good idea to have large documents in general. It's actually an anti-pattern in the database. Mm-hmm. But if you keep that to a minimal amount, that flexibility is helpful for developers and will work totally fine. But we just want to make it as flexible as possible for certain use cases that need that.
Got you. And the other announcement I saw was around the security side of Cosmos DB as well.
So we released a feature called role-based access control. So this is really important for enterprises too, because imagine you're launching a Cosmos DB database account. You have many databases and you have many collections. You want to be able to audit what your users are doing, what are they accessing, and be able to limit user access based on the collection. Based on the database that they need to use. You don't want to give people God credentials to your entire database account. So as your company gets larger, as you have more and more users accessing your database, this feature becomes incredibly important. And now it was in preview for several months. Now it's in GA, so it's recommended for everyone to use, which is really exciting.
And I guess, that'll fit in really well. I don't know if there's any built-in policies yet being set up within Azure policy for Cosmos DB. I'm assuming if they're not there, they're probably going to be there quite quickly. But even more so, we can probably develop some custom policy to manage these RBAC permissions ourselves as well through our kind of tenants.
Yeah, exactly. Yeah. So there are built-in roles, and roles are essentially a set of privileges that you have, and these roles, for example, read or read write, those are very easy to understand. But there's a certain available privileges and roles that are built in. But you can also create your own roles and decide which privileges and assign those roles to resources. For example, Gahl can have read write privileges on collection X or database Y. So there's a lot of flexibility there, but there's also these built-in roles which will cover most use cases and just make it much easier to iterate when you're assigning privileges.
So did you say these can be assigned at the container level? So the database container inside the Cosmos
Yeah, yeah.
DB instance itself.
Containers is similar to like a table in relational databases, and it's also similar to a collection in MongoDB terms. So collection is essentially equivalent to a container in Cosmos DB, which is why I'm saying collection over and over again.
Yeah, it's one of those things. There's lots of interchangeable words in my experience. So yeah, what one thing means something different, but the place basically where the data lives, essentially, it's like you say. That's my understanding, is that the container is effectively the database table, effectively with
and the database holds many containers or collections in the API for MongoDB terms. It's also worth noting. I remember. I think you mentioned instances. So these Cosmos DB in general does not, we're not. It's a multi-tenant database, so we're actually reserving capacity in our giant pool of resources. When you create a database account, we're reserving capacity for you. And when you create a container collection, etc., you specify the number of RUs, or if you're using autoscale or serverless, and that just reserves, reserves a spot for you for capacity and for you to be able to increase capacity up and down instantaneously. So that's why you're able to scale up and down so much, is because it's a multi-tenant database, and we're just getting resources from you from our gigantic pool of resources. We're not actually launching 3 instances for you in the cloud, and that's only for you. Does that make sense? It's a tiny bit different than many other database services too in the cloud. So
I mean, just on that note as well, from that high availability perspective, I was reading some notes on Cosmos DB, and it looks like it offers that 5 nines availability across, like you say, across the spread of the data centers. I don't know, Gahl, is that configurable in terms of where you spin this up, or is it like any Azure resource that we spin a Cosmos DB up and it's within a region pair? How does that work?
So it's actually I would say almost fun to configure, because it's pretty easy. So you just go here, and this is a new account with only one region specified. But you can configure multi-region rights, and then you essentially just click on every region you want to launch in. And if you have multi-region rights enabled, that means you can also write to all of those regions. If you have it disabled, that means you can read from the region and only write to the primary region. So it's super easy to configure. You can even take it off afterwards if you decide you don't need it. Very, very easy.
So it is like that multi-master write, effectively, that you can write in whatever region and it will all find its way back. So when you see that it's ACID, in terms of when a write happens, I'm presuming, does it wait for that write to happen across all of your write-enabled instances, or, is it one that it will just synchronize over time?
There's conflict resolution that takes place if there's conflicting writes. So you're not going to wait that way. You get low latency. So it'll make sure there's, I believe it's a quorum within the region that you're writing to, and afterwards, if there's a conflict, there's configurable conflict resolutions that will take care of that.
With you,
but yeah, basically, your write leads to the data center will be durable no matter what in every.
No, that makes sense. How many regions can we write to? Do you know, Gahl? Is there an upper limit on that? Is it 2? Is it more?
How many what can we write to?
How many regions? How many global regions can we turn this on for?
I believe it's for as many. I'm not aware of a limit. Maybe one exists, but you can basically enable as many regions as you need. There's also a cost associated with that, so I wouldn't just go and click the button for everything, because your costs are just going to add up and add up. So it's important to figure out what your use case is and what regions you need to utilize. But it's very flexible.
I guess this is perfect for when you've got user bases out in the regions. You can hold that data locally and a writable version of that data, so that it can be used with that application in the region or the surrounding areas, and be synced back across to the other region within your global kind of application footprint. So, no, that's pretty cool, Gahl. Yeah, I mean, it's great to see. I mean, are there any other areas of Cosmos DB that we can go into now, Gahl? Treat me like I'm a complete novice on this stuff here.
I have so much to talk about. So I kind of covered 16 megabyte, raising that limit, and when to use it and when to not. Don't use it when all of your documents are large. You shouldn't have large documents in general. It should just be the exception, and that's when it's a good use case to have large documents, when it's the exception, and we're just making that more flexible for you. Role-based access control is really important for enterprises and for people who want to be able to audit their users' actions and limit access and access to certain areas of their database. And one important thing I want to kind of cover is how in the API for MongoDB, how new features are enabled. So this is a Azure Cosmos DB for MongoDB account. You simply go to features, and all these features you see here are essentially behind feature flags. And what that means is when you want to get additional value from the database, it's almost instantaneous. It's a few seconds to enable features, and this includes what we call server version upgrades, which means you're getting new features from later versions of the MongoDB protocol, and that's really nice because our code base essentially has all the features and all the versions within it, and just has feature flags controlling it. So you can decide for your application what makes sense to enable or disable, and there's no rolling restart. There's no waiting period or downtime at all to or the stress that's associated with that in order to gain this additional value from your database. And as we add new features, we just keep adding to this list. So for example, with role-based access control, you just press enable, and this will get enabled. And you can also do the same for 16 megabyte documents, etc.
Cool.
So it's super easy to use.
Oh, that's cool. And I guess like everything that can be programmatically enabled or disabled based on your needs. I mean, is there any overhead, Gahl, that you're aware of with turning these features on with the product itself that's noticeable, or are they just
no
impact, essentially?
It's essentially just flipping a bit for this feature flag, and then when the feature's running, there isn't overhead for that either. So
cool. Very cool. Very cool. Yeah, and clearly, I need to start learning a bit more of this in a bit more depth, because I was going to ask you, Gahl, in your experience now in the position that you were in with Microsoft, are you starting to see like that de facto usage of Cosmos DB, in terms of cloud non-relational document databases? Is there a common theme starting to come through for when they're used, or is there not a theme and they can be used for anything and everything? Because you mentioned earlier that applications involving IoT, can understand that, and other areas. What are you seeing at the moment?
Yeah, so there's many different areas of customers that I would say like all across the world of different use types that they use the database. But I think the main kind of joining factor between them is one, high availability is really important to them. Like a lot of applications right now, across all industries, it's really important for them that their application does not go down no matter what happens. And they choose Cosmos DB because we have those, the 5 nines of availability, and that means that their application is pretty much guaranteed to stay up, and we stand behind that. And the architectural tech behind it allows that to happen. So that's kind of one angle. The second one I would say is the elasticity of Cosmos DB. Since we're a multi-tenant database, we can scale up and down instantaneously to meet users' needs. So imagine we have like a Black Friday, which is like a huge shopping day here, and there's an enormous spike in workload, for certain sectors, like for example, shopping. With Cosmos, you're very well protected there, because as long as you have autoscale enabled, your database will scale instantaneously to meet your users' demands, and you'll pay for what you're using, but you'll only pay for the period of the spike. That's it, and then it will go back down. It'll scale up instantaneously and back down very quickly. So you're not overpaying, but your users do not notice a performance issue, and your developers and operators are happy with what's going on, obviously.
That makes a lot of sense, and it's akin to the platform as a service components that we've become to love and get in kind of endearment with hyperscaler platforms like Azure. So I mean, it's great to see that Cosmos DB seems to be leading the charge there for that back end DB product, and no document DB, document DB, no SQL DB. That seems to be enabling a lot of different industries and application developers to kind of break into this world to speed up that process and that kind of go to market of an MVP for an app. So yeah, it's great to see.
And just to touch quickly on the third one, so we said elasticity, we said high availability, also integrations within the Azure platform. If you're using Azure, you don't want to have to develop these connections, and not just develop them, but also support those connections across different services. You want to just click a button and use it. So, for example, we have a Synapse link, which ETLs your data from the database to an analytics store and allows you to do all that stuff there with no work from your end. We actually have documentation around our integrations, which lists all of our integrations with other Azure services. And this is huge for customers because they don't want to build this out. Developers don't want to build this out. They just want to use integrations and focus on what they do best instead.
Yeah, I mean, I see some of the integrations with Azure Functions as well. Just the way that you can kind of just hook Azure Functions, like you say, without developing out that that whole connection piece is great, and it's great to see the advances there. So yeah, super keen to kind of learn a bit more and start using these services in a little bit more anger from my perspective. Gahl, I mean, that's been great. Is there any other areas we want to touch upon now before we bring this episode to a close? That's been fantastic.
I mean, that's it. I think we covered a lot today.
Yeah, no, really appreciate you coming on, Gahl, and kind of taking us through, Azure Cosmos DB, the API for Mongo DB, how we can kind of get started and use that. And if I'm right, there is a lower end SKU, a lower end tier that we can kind of just jump in and turn this on and get started with this pretty much from the get-go quite quickly, Gahl.
Yeah, there's a free tier with 1,000 request units, which is the way you kind of provision Cosmos DB, and they'll stay free for you.
Yeah, so it's quite easy to get in and learn some of this new stuff. So, look, Gahl, can't thank you enough. Thank you for coming on and being such an awesome guest and taking us through all of that. It's been a pleasure. Thank you very much for joining me.
Thanks, John.
See you very soon. Bye for now.